Hello, I'm Sean Smith, and today I'm going to show you how to implement and test your design on the Intel DE-10 Lite FPGA board using Intel Quartus Prime Software in just 5 easy steps. Without further ado, let's get right into the video. Step number 1, project setup. Start a new project and make sure the name of the project matches the name of the entity in your VHDL or Verilog code. In my case, the name of the entity is hex_display in my code, so I'll enter that here. Now we're going to press next a few times until you get to this screen where it asks you to choose your device. Since we are using the DE-10 Lite as our board, we are going to select Max 10 as our family. Then we're going to look for and select the device 10M50DA-F484C7G. So once you have that selected, go ahead and press the next button. For our simulation tool here, we're going to choose Model Sim Altera. In my case, I'm using VHDL, so I'll select VHDL as the language of choice. Then when you're finally done, click Next and Finish. Step number 2, creating your VHDL or Verilog file. Go ahead and select File, New from the top menu. And if you're using a VHDL file like me, select this option. Otherwise, select New Verilog file as your choice. I already went ahead and prepared a code for a 7-segment display driver. This code will convert any 4-bit number to a 7-segment display number. So I'm going to go ahead and copy and paste this code into the Quartus Prime. I'm going to quickly correct some of the formatting that was lost from copying and pasting the code, and then we will go ahead and save it. Make sure the name of the file represents the name of the project as well as the upper level entity. In this case, it'll once again be hex_display. After you have the correct name entered, go ahead and click Save. Step number 3, setting up the pin planner. In this step, you will enter the pins that may be found in the official Intel DE-10 Lite FPGA board manual. In this example, I'll be mapping my 4 input switches to the 4 switches on the DE-10 Lite board. Finally, I'll map my 7 inputs from my code to the 7 pins on one of the 7-segment displays contained on the FPGA board. Step number 4, full compilation and uploading to the board. Go ahead and select a full compilation. This may take a long time depending on how big your code is. After it's finished, go ahead and select Programmer from the drop-down menu. Next, you will go to Hardware Setup, and from the drop-down menu, select USB Blaster, and then exit this window. Now go ahead and click Start to upload the code to the FPGA board. The progress bar will tell you when the code is fully uploaded to the DE-10 Lite. Step number 5, testing your design on the FPGA board. In this example, you may now notice that if we toggle the 4 switches, the value of the 7-segment display changes. If the switch is up, it represents a 1, and if the switch is down, it represents a 0. Depending on the corresponding 4-bit number, it will now be shown in decimal on the 7-segment display. The design works and is a success, so we know that the hardware has been successfully synthesized and implemented.